Hello, Honors Algebra 2. Today in class you will be listening to this video, which is going to take us through day 1 of simplifying fractional exponents. We will pick up with this again tomorrow, and I will be in tomorrow morning, so you are more than welcome. Please come at 7:30, and I'm happy to walk you through any of these problems that you didn't understand in the notes. We are actually going to skip the warm-up for time's sake. We're going to come down to the new stuff, but the answers to this are on Canvas, so you're welcome to go ahead and check out the answers for 1 and 2 at your leisure. All right, so we're going to start with what you're already used to, working with roots. You know that 4 squared is 16, and therefore the square root of 16 is just 4. We don't say plus or minus 4 because we're not taking the square root of both sides, we're just saying square root of 16. That's always the positive. Well, so it turns out there's another way to write square root of 16, and it uses this idea over here. The nth root of a number a, where n is called the index, can be written like this. So a lot of times you have a cube root or a fourth root. When you have a square root, your index is really a 2. We just don't put it there. Okay, but what this is really saying is that we have 16 to the 1/2 power. Okay, square root of 16 is the exact same thing as 16 to the 1/2 power. So notice the exponent inside, so in this case it's just a 1, becomes your numerator, and the index of your root becomes your denominator. All right, let's try it again. 2 cubed, you know, is 8. Cubed root of 8 is 2. Okay, we're just going backwards. This can be written as 8 to the exponent over index, 8 to the 1/3 power. All right, so 1/3 is an exponent in this case, and these are just two ways to write the same thing. -3 cubed is a -27. The cubed root of -27 brings us back to -3. And again, this can be written as a -27 to the 1/3 power. The 3 is the index. It always goes on the bottom of your fraction. All right, so let's try some of these. We're going to just rewrite it in exponent or radical form. So these top 3 are already in radical form. We will write it in exponent form. So this is an a to the first. It becomes a to the 1/3. Second one, also an a to the first. So this becomes a to the 1/4 power. Again, that index always becomes your denominator. Okay, and the index is this number outside of the root. All right, here we go. A to the 1, we're taking the 5th root. This is the same as a to the 1/5 power. All right, so it's really important that you get comfortable moving back and forth between radical form and exponent form. When we have final answers, we always want radical form for the most part, but some people prefer one method to another, and so they might switch back and forth between the different forms. They might stick with one. It really doesn't matter, but you do need to be familiar with them and comfortable with going back and forth. All right, so now these are already in exponent form. We're going to change them to radical form. So start by making a root. Put your base, which is a b, inside. Denominator is always your index. And I'm just going to put a little 1 there just so I can see that 1/12. But feel free to not have the 1. X to the 1/2 power. Start with a root. Put your base. This index, or excuse me, this denominator is always your index, but we normally don't put a 2. It just means it's a square root. And this is exactly the same as square root of x. Okay, number 6, you do have to be careful. Because there aren't parentheses around this 1/6 power is just going to the y. That means that the 4x is just hanging out, okay, like it's not doing anything, has nothing to do with the root. Your denominator is a 6, that's the index, and you have a y or y to the 1 inside. If the whole thing was to the 1/6 power, then you would have the 6th root of this whole 4xy. Okay? All right, so make sure you're checking out if you have parentheses or not, because it does make a difference. All right, moving on. So these are things that we can calculate a couple different ways in our heads or with our calculators. All right, so use your calculator to evaluate the following in both exponent and root form. Always use parentheses around rational exponents, then evaluate by hand. Okay, so we're going to first do these two with our calculator. Now, I know that you know what square root of 100 is. The point is, do you know how to type it into your calculator? So two different ways you can do this. If you want to type in literally 100 to the 1/2 power, we can use our exponent. Now, if you have the new operating system, you can literally just type in 1/2. However, if you have the old operating system, when you do raise that exponent, and I know it will look a little different, you are going to have to put parentheses around it, okay, just like you would any other fraction. You can also use that alpha y equals enter if you would like, and put in the 1/2 that way. I think it's probably more keystrokes, but you'll get 10 as well. Okay, square root of 100, we know it's second, and then our square root button, and you can get 100. Either way, both of these are 10. Okay, so that's using our calculator. Just typing it in, making sure you can do that. By hand. Again, obviously we know the answer is 10 for both of these, but let's just talk about how you can do this two different ways. Square root of 10, we'll do the bottom one first. Most of us are familiar with these factor trees that we've done. Factor trees are going to be a big thing in this unit. The key with the factor tree, it's a square root, so you are looking for pairs. We have a pair of 5s and a pair of 2s, and we will multiply those together. 5 times 2 is 10. Because there isn't any non-pair, anything left over, there's nothing left underneath the square root. It's literally just this 10. Okay. All right, now another way to evaluate this is from exponent form. 100 is the same as 10 squared. So I can rewrite that, and then it's to the 1/2 power. Our laws of exponents say that we would multiply these exponents together. 2 times 1/2 cancels, and you're left with 10 to the 1, which is still just 10. This is a really good method to use. If you can rewrite something as a smaller base, it is always going to be beneficial to you. Okay. All right, so 64 to the 1/6 power, we're going to do these again with our calculator, just making sure you can type them in. So 64 to the, remember parentheses, especially if you have the older operating system, and you get a 2. To get a 6th root, what we're going to do is we'll go to math, and you can go down to option 5, and that little X there allows you to pick any number you want inside of your root. You do have to be careful because it's a little like, see how it pulled up answer as my index? So you've got to be careful about that. You can just fix it to anything you want, and then we're doing 6th root of 64. I also noticed that if you put the index first and then go to math and go down to option 5, it automatically puts it as the index. I have a feeling that's just for the new operating system though. So just be really careful when you're typing that in that you're actually putting the numbers where you want to put them. All right, so let's try these by hand methods again. These are going to be a little different because as far as I know, you haven't taken the 6th root of a number by hand before. So we're going to start off with 64. Remember, when you're in exponent form, my suggestion, like we had with 100 to the 1/2 power, was writing this with a lower base. So 64 is the same as 8 squared to the 1/6 power. Okay, multiply your exponents. This is 8 to the 2/6 power, which is 8 to the 1/3. All right, now technically this is the same as the cubed root of 8. However, we can actually break down this 8 further. 8 is the same as 2 cubed. Raise that to the 1/3 power, and now we'll see that when we multiply these exponents, we just are left with a 2, which is the same as the cubed root of 8. All right, so you can see there are already a bunch of ways that you can do this type of problem. If you are in radical form and you prefer the factor tree method like we did with square root of 100 here, you're going to do the same thing as you did with the square root of 100. Break it down as much as you can. Lots of 2's. Okay, specifically there are going to be 1, 2, 3, 4, 5, 6 of them. So you could write it like this. However, what most people usually think of is whatever the index is how many of the number you need in order to pull one out. So in a square root, you are looking for pairs. In a sixth root, you are looking for groups of 6. Okay, so you need a group of 6 in order for any number to come out. I have 1, 2, 3, 4, 5, 6 2's, so a 2 can come out. If you had any leftover numbers, those would go underneath the sixth root, just like you would do with a square root. All right, let's give some of these a try. Okay, so we're going to let n be an element of integers, and a is an element of all real numbers. Again, what we're doing here is the nth root of a. So first, let's just plug our numbers in. It's the 5th root of negative 32. All right, so we'll get more into this, but whenever you have an even root and you have a negative inside, you're always just going to have a negative that comes out in your answer, okay, whenever it's an odd index. I think I just said even index. Whenever it's an odd index, you can just pull the negative out, okay, and we'll talk more about that tomorrow. So just worry about the 32. Break down a 32 any way you want. 16 and 2, 4 and 4, 2 and 2, 2 and 2. Because my index is 5, I need a group of 5 in order for 1 to come out. 1, 2, 3, 4, 5. Okay, so a 2 can come out, and it's going to be a negative. There you go. All right, let's try another one. The nth root of 64. So the cubed root of 64. We'll do a factor tree. 8 times 8, 4 times 2, 4 times 2, 2, 2, 2, 2. Look at your index. Your index says it's a 3. That means we need a group of 3 in order to pull a number out. I have one group of 3. I have another group of 3. 2 times 2 is 4. And that's your final answer. All right, one more of these. N is your index, and A goes underneath. All right, now, this is different from number 9. Number 9 had an odd index. Number 11 has an even index. Even indexes cannot have a negative underneath, okay? Just like we can't have a square root that is negative. Or a negative underneath the square root, I should say. That's when we start having imaginary numbers. But imaginary numbers are only for square roots. We are dealing with a 4th root right now. So we just say that this is undefined or undefined over the set of real numbers. Okay, you cannot take the 4th root of a negative. If you type it into your calculator, you will get an error. Go ahead and try it if you'd like. All right, so you've noticed right now that we've just gotten integer values for each of these, but as you know, I mean, most of the time when you have a square root and you do a factor tree, you end up getting something like 2 root 7 or 3 root 5. And that is what we are going to look at next. So, basically what all of this terminology is saying, which we will talk more about tomorrow, but the key thing here is, again, the numerator represents the exponent and the denominator represents the index. So these are going to be problems that do not simplify necessarily quite as easily. Okay, that might be a little harder. And then we'll get to some more complicated ones in a little bit. All right, so 16 to the 5/2. If you want, you can change this to radical form. Put the 16. Denominator is your index. Numerator is your exponent. Here's the thing. 16 to the 5th is a really big number. You probably don't want to do 16 to the 5th and then have to do a factor tree with it. That is a lot of work. So instead, we're going to look at this a little bit different way. For starters, 16 is the same as 4 squared. That gives me 4 to the 10th. Okay. But 4 can also be rewritten. We always want to go as low as we can here because otherwise you end up thinking it's simplified and it's really not. So 4, and I guess I'll get rid of this 2 because technically it doesn't need to be there because it's a square root. 4 is the same as 2 squared. So when you multiply your exponents again, we have square root of 2 to the 20. Okay, so remember, your index here is a 2. This is saying that you have 20 2's. You need groups of 2. So a really big thing that we are always going to say is we are doing exponent divided by the index. Okay, you have 20, you need groups of 2. How many are there? 20 divided by 2 is 10. That means 10 2's can come out. And 2 to the 10th is 1024, which would be your final answer. All right, so now, is there another way to do this? Well, yes, of course there is. If you don't like dealing with the radicals, you can rewrite 16 as 4 squared here. And then what actually happens quite conveniently, even though 4 can still be rewritten as 2 squared, is that these 2's cancel and we get 4 to the 5th, which if you type into your calculator is also 1024. I cannot really tell you which way will be faster. It really just depends on the problem. It's going to be something that you just start to get a feel for. Okay. 64 to the negative 2/3. We are going to skip this. We will come back to something like this tomorrow. All right, laws of exponents apply to rational fractional exponents as well as integer exponents. Unless otherwise stated, all answers should be written in simplest radical form. Meaning if you end up with an exponent, a fractional exponent, you do need to make it a radical. Okay, so we'll practice that. Keep in mind, again, what I mentioned before, when simplifying, we divide the exponent by the index. All right, so here we go. These are the ones that aren't going to simplify too nicely. But people don't do too badly with these. Just start doing a factor tree, okay? Keep it like what you have normally done. And your index, again, tells you how many numbers you need to make a group. So I am looking for groups of 3. 1, 2, 3. These guys, I don't have enough. I only have 2 of them. So I'm going to underline those. My circles come out. 2 cubed root of 2 times 2 is 4. All right, so same rules as with square roots. Just don't forget this index, okay? That happens a lot. You know, if you're one of those people that forget random things, okay? That is something people forget, is their index. All right, let's try another one. 648. All right, just for time's sake, I'm going to tell you some numbers that this multiplies to, but you can choose whichever numbers you want. 648 is 72 times 9, if you didn't know that. 72 is 9 times 8. 3 and 3. 4 and 2. 2 and 2. 3 and 3. All right, we are looking for groups of 3 again. 1, 2, 3. 1, 2, 3. And I've got a 3 left over. So the 3 that underlined goes inside. The 3 and 2 I circled get multiplied. 6 cube root of 3 is your answer. All right, let's keep going. Okay, so just as when you had something that was x squared times x to the third, and you would add these exponents and get x to the fifth, we are doing the exact same thing in number 15. Your base is the same. You have two 7s. They stay a 7. Okay, notice x, x, x. Base always stays the same. And we are just going to add our exponents together. So 1/2 plus 2/3. Please remember that you do need a common denominator, so unless you want to, make a common denominator, please use your calculator and MathFrac, and you get 7/6. So 7 to the 7/6 power. So now this needs to be written as a radical. Denominator becomes your index. Numerator becomes your exponent. Okay, so what you are looking for is if your exponent is ever bigger than your index. Because this 7 is bigger than 6, that means that there's a number that can come out. Okay, because you're looking for groups of 6. So ask yourself, 7 divided by 6, how many times does that go in? Once, with a remainder of 1. That means that 1 7 comes out, and the remainder, 1 7 stays in. Okay? All right. 16, we're going to skip. We're going to go down to 17. Okay? Your exponents will distribute. You cannot, usually, I should say, you cannot multiply these things. In this case, since they're both to the third power, it would be fine. But in general, I would recommend just distributing this exponent first. So 3 times -1/3 is -1. 3 times -1/3 is still -1. Remember, negative exponents make us go to the denominator. And now you just have 1/4 times 1/2. We can just multiply that together and get 1/8. Notice that you could do that here as well. You can multiply the 4 and the 2 to get 8 to the -1, then move the 8 down. But again, the only reason you can do that is because these are the same. I don't want you to get in the habit of doing that, because if the exponents are different, it's not going to work. Okay? All right, next. When you have the same base and you are dividing, we subtract our exponents. So for example, if you have x to the 7th over x squared, we do 7 minus 2 is 5. So we're just going to do the same thing here. Bases are the same. This exponent is a 1. 1 minus 3/4 is 1/4. Think to yourself, can you break down a 6 anymore? Like, is that a perfect square or anything like that? Well, no. Like, it's not 2 cubed or 2 squared or anything like that. So the 6 is fine. And now we'll just put it in radical form. Denominator becomes your index. Numerator is your exponent. So this is the 4th root of 6. All right, number 19, I would like you to give a try on your own. This is just like number 14 and 15, where you're going to do your factor tree. You are going to look for groups of 3s. Your final answer should be a 3 cubed root of 6. Okay, and we can review that tomorrow. Okay, I want to get to a couple more of these. 22 we're definitely going to save for tomorrow because this one's a little tricky. So if you see one like it on the homework, just kind of skip it. We'll come back to it. We'll hit this one a bunch over the next few days. Number 20, this one is actually pretty easy. Whenever you have two of the same type of roots, you can just multiply them together. Like if you had root 2 times root 5, both are square roots, you would multiply them and get root 10. So both of these are cube roots, so we're just going to multiply them. 25 times 5 is 125. Cubed root of 125, and now we'll do a factor tree. And we are looking for groups of 3. 1, 2, 3. Nothing's left over. 5 is your answer. All right. 21. 21 looks the same as 19 and 14 and 15, but it's got one more component to it that we have to be careful about. All right, so couple ways you can think of this. You can do a factor tree, which is fine. I want to think of it as like this. 64 I'm going to rewrite as 8 squared. Now, here's the thing, and this is where it gets really tricky. I told you that you need to make sure that your exponent isn't bigger than your index, because if it is, it means you can pull a number out. Now, right now, it doesn't look like you can take any number out because the exponent is a 2. The problem is the 8 isn't broken down all the way, so it really does have some extra numbers that can come out. 8 is the same as 2 cubed. All right, so we had an 8 squared under here, but what we really have is 2 cubed to the second power, which is 2 to the 6th. So now it's like, oh, wait a minute, this exponent really is bigger than this index. All right, so exponent divided by index, 4 goes into 6 once with a remainder of 2. That means 1 2 comes out and 2 2's are left over, which you would multiply to 2 squared is 4. But if that isn't tricky enough, this problem has one more part about it. I want you to look at this. If you were to rewrite that in exponent form, it would be 2 to the exponent over index, 2/4 power. I don't know about you, but in my class and in every math class you've ever taken, it is never appropriate to leave something as 2/4. Okay, you are always going to simplify it. 2 to the 2/4 power is the same as 2 to the 1/2 power, which means that this part right here, this isn't simplified. You need to rewrite it as a square root of 2. So your final answer is 2√2. This one is rough. There are lots of places to make mistakes with that. Don't worry, we will be going over it. All right, we're skipping 22. These last two are super quick, I promise. I know this video has been very lengthy. I know, I am sorry. All right, so just like you can multiply a square root by a square root or a cube root by a cube root, you can do the same when they're dividing. It's the cube root of 32 over the cube root of 4. 32 over 4 is 8. And you can do your factor tree if you'd like, or you can look at it like this. 8 is 2 cubed, and then these guys are just going to cancel out, because 3 divided by 3 is 1. Exponent divided by index. You just get a 2. If you don't like that and you're like, Miss Bramer, what are you doing? Just do your factor tree. You're looking for groups of 3. 1, 2, 3, and the 2 comes out. All right, last one. Yay, you've been great. Or at least I assume you have, because I can't actually see you. You have the 6th root of 49. Always rewrite. So you could do 7 times 7. But here's the thing by doing the factor tree here. You're looking for groups of 6. You don't have a group of 6, but that doesn't mean this can't be simplified further. Because if you look at this, you have 2 7s. This is the same as 7 to the exponent over index, 2 over 6 power. That's not cool. We can't deal with that. This is the same as 7 to the 1/3 power, just math fracking this. And then always, always, always radical form when you're done. Okay, your exponent is your numerator. Your denominator becomes your index. So cubed root of 7. All right, so I hope that was sufficiently exciting for you. We will talk about more of these problems tomorrow, I promise. Yes, this is confusing at the beginning. Okay, so if you are confused, don't worry, you're probably in the majority. We will have lots of review prior to your quiz on Wednesday. Please remember, I am available before school tomorrow to answer any questions you have, as well as after school, as long as you can find a ride home, because there will be no late bus. Okay, have a wonderful day. Please do your best on worksheet 1. We will go over lots more problems like this tomorrow. See you later.